Welcome to Brain Vision.
Let's find the differential of the given function. And here, notice that L, we can rewrite this as L of x, y, z. These are our variables. So that the formula dl, that's the differential of L. So first we'll have the differential of L with respect to x, and then multiply that by dx. Derivative of L with respect to y times dy. And don't forget the third variable here, z. So partial derivative of L with respect to z, and then times dz. So we'll need to go ahead and compute these three quantities, these partial derivatives. So first one, derivative with respect to x. So we just differentiate that. That goes away to a 1, and we're left over with ze negative y squared minus minus z squared. So we can go ahead and plug that in for the first part. So it's a minus z squared. And then don't forget the dx. So next, let's go to the partial derivative of L with respect to y. So this time, when we differentiate, we have a y in the exponent. So then we'll have to use the chain rule to differentiate the exponent with respect to y. So we get a negative 2y out of that. So let's write this as minus 2xyz, and then e negative y squared minus z squared, and don't forget the dy. And we have one more term to go here, lz, dz. And this time we will need the product rule because we see z appearing in two different factors. One's here, and then also in the exponent. So use the product rule there. If you differentiate z, it just goes to 1. And then for the next term, when we differentiate, we'll still have our xz. But when we differentiate the exponent using the chain rule, we'll get a negative 2z. So there's the negative 2, and then the additional factor of z gives us a z squared there. So this will be minus 2x z squared e negative y squared minus z squared. We've been very careful here, and include the dz. And there's our final answer. So dl and these expressions on the right give us the differential of L. That's our final answer.